Good evening, students. Welcome to the class of Technomathematics. So today we will be solving one question where it's given that the two resistances are there. Okay. So the two resistances which are connected once in series and once in parallel. Okay. So let's say the two resistances. Let the two resistances as R1 and R2, right? So let me just set it. Yes, yes. So let R1 and R2. Now it's fine. So let R1 and R2 are the two resistances, right? Two resistances, right? Now we need to find the value of R1 and R2 when it's given that the equivalent resistance when they are connected in series. When they are connected in series, that means for an electrical circuit, if two resistances R1 and R2 are connected in series, the connectivity will be looking like this, right? And here it can be a power source, a voltage, battery, whatever, right? So here if this is R1 and this is R2, then the equivalent resistance over here, R equivalent, can be written as R1 plus R2. I think you remember this formula, right? And here the value of this equivalent resistance is given to you, and that is given as 18 ohm. 18 ohm, right? So 18 ohm is the equivalent resistance of a series connected circuit, of a series connection between R1 and R2. Now, when the same resistances are connected in parallel, they will be having an equivalent resistance of 4 ohm, right? So if the same resistances, they are connected in parallel, so if let's say this is R1 and this is connected in parallel with R2, right? In parallel with R2, and let's say there is some power source or voltage source, whatever. So what will be the equivalent resistance? Okay, so first of all let me write it over here. This was series connection, right? This was series connection, and this is parallel, right? Parallel. So here the R1 and R2 are connected in series, and here R1 and R2 are connected in parallel, right? So it's given that R equivalent for the parallel connected circuit, R equivalent is given to you as 4 ohm, right? When they are connected in parallel, right? Now what we will do, we will simply use the formula of a parallel connected circuit. For a parallel connection of R1 and R2, R equivalent can be written as 1 by R equivalent can be written as 1 by R1 plus 1 by R2, right? Now our resistances are R1 and R2, and we need to find the value of these resistances. This was the question, right? Now what we will do, we will just put up the value of equivalent resistance over here, that is 4 ohm. So here we get 1 by 4 equal to 1 by R1 plus 1 by R2, right? And this will give you R, that is 4, equal to R1 R2 by R1 plus R2, isn't it? I hope this is R1 plus R2. This is the basic formula of equivalent resistance. Okay. So here we have two equations with us. One equation was this one, R1 plus R2. The value was 18 ohm, and the second is this one, 4 times R1 R2, 4 equal to R1 R2 by R1 plus R2, right? Now just use this value of R1 and R2, use this sum of R1 and R2 and just place it over here, right? When you place it, it will be coming like this: 4 equal to R1 R2 by R1 plus R2. In place of R1 plus R2, use the value of 18. So we can write it like this, right? So This will give you the value of R1 and R2, that is, this will give you the value of R1 into R2 as equal to 4 into 18, which is coming as 72. So R1 R2, the value of R1 R2 is calculated as 72. Okay, so now this value with you, R1 into R2, is coming to you as 72. Now to calculate the value of R1 and R2, what we will be doing forward? The next step here. Let us see. Since the product is known to you, sum of this is known to you, just use the formula of R1 minus R2 whole square. Why we are using it? I am explaining it. Right? So, since R1 minus R2 whole square can be written as R1 plus R2 whole square, right? Then here you can see plus 2 R1 R2 will be compensated with subtracting that, and again minus 2 R1 R2 for this. So this will be looking like this one, 4 times R1 R2. I hope this step is clear to you. Here when you expand the RHS, that is R1 plus R2 whole square, here you will get 2 times R1 square plus R2 square plus 2 R1 R2. But when this is not over here, okay, then 2 times R1 R2, instead of 2 times R1 R2, here into the LHS R1 square is there, R2 square is there, but it's minus 2 times R1 R2. But here into the RHS, after R1 square R2 square, we have plus 2 times R1 R2, but we need minus 2 times R1 R2. Then only this equation will be, there will be equal, the validity of this equality will be there, right? So that's why instead of plus 2 R1 R2, we need minus 2 R1 R2. So plus 2 R1 R2 need to be subtracted, and after that again minus 2 times R1 R2 just to compensate the LHS R1 R2. So finally we are subtracting minus 4 times R1 R2. So then only this equation will be valid. The LHS will be equal to the RHS, right? Now just calculate the value of R1 minus R2. So from here we can see R1 minus R2 whole square is equal to R1 plus R2 whole square. That means 18 ohm, 18 square minus 4 times R1 R2, 4 times R1 R2, R1 R2 is 72, so 4 times 72. So this will give you, just solve it, 18 square. What is the value of 18 square? 18 into 18, it is 864, carry 6, it is 144, then 8, then 1, then 4, 324. So it's coming 324 minus 4 into 72, it's 8 and 28. So this will be, yes, so R1 minus R2 whole square is coming as 324 minus 288. So when you subtract it, you will get 36, right? So R1 minus R2 is calculated as, when this square will be eliminated after taking the square root, this will be root 36. So R1 minus R2 is coming to you, and this value is calculated as 6, right? Now we have the value of R1 plus R2, we have the value of R1 into R2, we have the value of R1 minus R2, right? So what we will do, just use this value of, just substitute the value of R2 from here, then we can write R2 as R1 minus 6, second resistance equal to first resistance minus 6. From this equation we can write it, and just use this value to put up into the first equation, that is R1 plus R2 equal to 18. So since R1 plus R2 is equal to 18. So we can say that R1 plus, in place of R2, just use this value of R1 minus 6, right? So when you use this, it will be R1 minus 6, which is equal to 18, and this will give you 2 times R1 is equal to 18 plus 6, implies R1 is 18 plus 6, that is 24 by 2. So the value of R1 is calculated as 12 ohm. R1 is calculated as 12 ohm. Now, since R1 is calculated as 12 ohm, we can say that R2 is, simply put up the value, R2 is R1 minus 6, right? Since, therefore, we can say R2 is R1 minus 6 using this formula, right? What we have derived, right? So R1 minus 6, that means 12 minus 6. So R2 is coming as 12 minus 6. That means finally the value of R2 is calculated as 6 ohm. So we get the value of R1, we get the value of R2, and in this way we have solved this question. I hope you like this, and definitely, what was the question? Let me repeat it again. The question was that two resistances are there. Okay, so we have assumed both resistances as R1 and R2, right? Now, into the numerical, it's mentioned that when the same resistances, that is both these resistances R1 and R2 connected in series, they are having an equivalent resistance of 18 ohm, right? And when the same resistances are connected in parallel, they are having an equivalent resistance of 4 ohm. We need to find the value of R1 and R2 is equal to what, right? Now what we did, we simply use the formula for equivalent resistance of a series connected resistances. Here equivalent resistance is R1 plus R2, which is coming as 18 ohm, right? So this is one of the equation which is derived, and when they are connected in parallel, we know that R equal to R1 R2 by R1 plus R2, right? Here this one, R equal to R1 R2 by R1 plus R2. So we use this formula and put the equivalent resistance of both the parallel connected circuits, that is given to you as 4 ohm. So we get the equation R1 and R2 is equal to 4 into 18, which is equal to 72, because here we place the value of R1 plus R2 here, that is 18 ohm. When you place this value over here, you can see I have placed this value over here. Then finally we get the product of R1 and R2 as 72. Now just we use the formula of R1 minus R2 whole square equal to R1 plus R2 whole square minus 4 R1 R2. Why we did it? Just to calculate the value of R1 and R2 and having this relation. Okay, so this relation is derived, that is R1 minus R2 is equal to 6. So we have two equations with us. We have R1 minus R2 equal to 6. We have already given the first equation R1 plus R2 equal to 6. So using both the equations, we calculated the value of R1 by substitution method. We just substitute the value of R2 in terms of R1 and we solved it, and we get the value of R1 as 12 ohm, and by using the same equation we get the value of R2 as 12 minus 6. You can see R1 minus 6. So here it's calculated as 6 ohm. So in this way R1 and R2, both the values of resistances have been identified. One is 12 ohm, another is 6 ohm. So let me write it over here. So R1 is 12 ohm and R2 is 6 ohm, right? So the value of both the resistances have been identified, and in this way we have solved this question. Thank you so much for watching, students. Take care. Bye bye. For any query you can put up into the comment box, and for any kind of further clarity and for other selected questions, you can refer to the playlist on my channel, and definitely you will find it useful. Okay, and Don't hesitate. I've selected many questions which are conceptual questions, and all those questions can be referred. And for any query in any of the questions, you can directly drop a message into the chat. Through the chat I will respond to you. Okay, and thank you so much for watching. Bye bye.